Okay, thanks for the introduction. Yeah, I'm Haibo. I'm a assistant professor in Parallel Processing Institute from Fudan University. This is a collaboration work with Yijian Huang and my advisor Bing Yu Zhang. This talk is about optimizing the crash dump in virtualized environments. First, I'd like to say thank them for providing such a good source base. I always learn myself as a Zen PhD, since my PhD work mainly consists of many research projects enabled by Zen. And okay, some word advertising. And we started working on Zen at the beginning of 2004 after reading the SOSP paper, and found it very interesting. So I started with some projects, and the first project is to using Zen as a tool to update the Linux running on Zen, so that Linux, the new features to Linux can be updated on the fly without rebooting the Linux. And this is a live updating operating system using Zen. And then we found Zen had some performance penalty, so we decided to update operating system without Zen by dynamically inserting and removing a Zen beneath the operating systems. Also, we used Zen as a protection means to prevent or compromise the operating system from attacking its applications. So the virtual machine monitor, like Zen, will control the means that the operating system can access the memory of the application to protect the application from the malicious operating system. Also, we recently did some work on improving the scalability of Zen, since Zen has a very big domain lock, shadow lock to serialize access in Zen. But instead, our first approach is that instead of optimizing the shadow model of Zen, we decided to using multiple operating systems to run one single application and provide a system call virtualization layer to enable multiple operating systems to support one application. And by this means, the scalability of Zen can be greatly mitigated. Okay, here's some overview of our past project. And today I'd like to introduce some of our work on optimizing the crash dump in Zen environment. And I think Zhigang has provided a very good overview on crash dump and the analysis tools, including the tools provided by George. I think I do not need to introduce another sort of things about crash dump. So as has been talked by Zhigang, the crash dump is a default tool in Zen's environment. But the problem is that the code dump and the system reboot is serialized. We have first to dump the system and then reboot the virtual machine, and then the service can be again available again. So the downtime consists of two parts. The first part is the code dump, and the second is the system reboot. And by studying the characteristic of the crash dump process in Zen, we found that the crash dump process usually have a very low CPU and memory utilizations, but it's instead of an IO-intensive process. So we found there are several opportunities to optimizing the crash dump in Zen to shorten the downtime. So the basic idea is that in virtualized environment, the crash of the VM is not the end of the world. So the management VM is still alive. And in virtualized environment, there can be multiple virtual machines simultaneously running on the end. So our goal is to minimize the downtime for code dump and the recovery. So the proposed optimization is to concurrently dump the crashed virtual machine and start the recovered VM. So the basic scheme is that when the crash dump is on the fly, we simultaneously start another virtual machine running on the same disk image, so that the downtime incurred by crash dump can be minimized. We also use virtual machine-based introspection to do some selective crash dump to further minimize the downtime. As the crash VM, the dump of the crashed VM, as well as the recovery VM, will compete for the disk I/O bandwidth. We also provide some disk I/O rate control framework to balance the I/O bandwidth between these two virtual machines. Here's some of our design. Our tool is implemented as a demo in the management domain as part of the Zen tool. So the Zen tool, this demo will receive the panic from the domain, the production domain, in which the panic of this domain will issue a hypercall and then captured by the demo. So then we start another virtual machine named the recovery domain. So these two domains share the same file system, so that the persistent states can be retained even after the crash. This is something different from by caching or backup virtual machine, and when the primary virtual machine is down, and then using the backup virtual machine to serve the service. We also ensure that only one virtual machine can access the disk image, so that the sharing of the disk image is safe. So we first started the recovery domain, and while the code dump is still on the fly. Since in the normal way of crash dumping a virtual machine, the virtual machine, memory of the virtual machine is reserved by the crashed VM. So we need to break the tie of the reservation, so that the CPU I/O resource could be immediately released on crash. Also, to relinquish the memory from the crashed VM, we divide the VM's memory into chunks.